Hubble, our old space telescope, once spotted a blurry patch of light in the cosmos. For a long time, it wasn't clear what this light represented. However, the James Webb Space Telescope, JWST, has recently delivered a shocking revelation: this patch of light is actually a huge, ancient galaxy. The discovery of this galaxy, potentially older than time itself, could propel us into a new dimension of understanding space and challenge everything we know about the universe. The JWST has provided unprecedented clarity in observing this mysterious galaxy, now identified as GZ9P3. We now have detailed information about its size, mass, and stellar population. While Hubble had already hinted that GZ9P3 might be a well-developed galaxy, the images were too blurred to make definitive predictions. With JWST, we have entered a new era where this galaxy is revealed as a scientific sensation, possibly one of the oldest in the universe. It sounds incredible, but GZ9P3 might be older than the universe itself. This would mean we are not merely looking into the beginnings of the universe, but into an entirely new dimension of science. The discovery of GZ9P3 raises profound questions, especially since this galaxy could predate the Big Bang by billions of years, challenging our understanding of cosmic history and the origins of galaxies. Did you know that there has never been definitive evidence for the Big Bang? Cosmological models have been based on speculation, mathematical models, and probabilities. Until now, these models were widely accepted, but the JWST's findings regarding GZ9P3 could change everything. The galaxy's age and complexity suggest it must have formed before the Big Bang, pushing scientists to reconsider the established models of the universe's beginning. GZ9P3 is not just old, it's large, dense, and well-developed. Typically, it takes billions of years for galaxies of this size and maturity to form, yet GZ9P3 existed in its splendor just 500 million years after the Big Bang. This discovery challenges the idea that the universe was still young 13.3 billion years ago and suggests that rapid galaxy formation might have been occurring much earlier than previously thought. The existence of GZ9P3 forces scientists to rethink previous models of galaxy formation and evolution. Until now, the prevailing belief was that galaxies formed slowly over billions of years. However, the maturity and complexity of GZ9P3 indicate that massive and mature galaxies could have formed much earlier, leading to questions about the processes that governed the early universe. When Hubble first imaged GZ9P3, scientists were skeptical. The blurry patch of light could have been a massive galaxy or a very bright accretion disk around a black hole, both of which would have been significant discoveries. However, the data was inconclusive, and for years, researchers continued to believe in the traditional models of galaxy formation. The discovery was set aside, leaving many unanswered questions. With the JWST, the mystery of GZ9P3 has been solved. The telescope revealed that GZ9P3 is indeed a massive and mature galaxy, home to several billion stars. Its complex shape, including two dense cores, suggests it was formed by an early merger of galaxies. This discovery not only confirms GZ9P3's existence but also provides insights into the early processes of galaxy formation. To understand GZ9P3's structure, scientists have examined various morphological parameters, which quantify the shape and structure of galaxies. One key measure is the Gini coefficient, which for GZ9P3 is 0.61. This coefficient indicates that the galaxy's light is relatively concentrated, typical for a galaxy with a bright center or dense cores. These parameters support the theory that GZ9P3 was formed by a significant merger. Further analysis of GZ9P3 reveals that the light in the galaxy is distributed in a way that suggests complexity. The brightest regions of the galaxy are well distributed, further indicating that GZ9P3 has undergone significant mergers. Another measure, the asymmetry value of 0.35, shows that the galaxy has some irregularity or asymmetric distribution of light, often a sign of disturbances due to interactions or mergers. The data provided by the JWST has had a profound impact on our understanding of the universe. The telescope's observations of GZ9P3 suggest that the early universe was not as young as previously thought. This discovery challenges long-held beliefs about the Big Bang and the slow evolution of galaxies, indicating that the cosmos might be much older or fundamentally different than we've imagined. For nearly a decade, scientists eagerly awaited the launch of the JWST. When it finally launched, it brought a shock: the universe might not be as young as we thought. The JWST's images of ancient galaxies like GZ9P3 suggest that the universe might be older or that our understanding of its beginning is flawed. This discovery forces a re-evaluation of the Big Bang theory and the formation of the universe. Scientists have long theorized that galaxies formed through the gradual merging of smaller star clusters. Over billions of years, these clusters merged to form larger and more complex galaxies. However, GZ9P3 challenges this idea. The discovery of such an advanced galaxy so early in the universe's history suggests that galaxy mergers and complex formations were happening much sooner than previously believed. There are more than a dozen alternative theories about the origin and nature of the cosmos. Some suggest that the universe was already fully formed from a kind of blueprint, possibly from a predecessor universe or an unknown source. These theories, including the idea of a cyclical universe, propose that our cosmos might be infinite, with no true beginning or end. The discovery of GZ9P3 lends some credibility to these alternative models. We are living in an exciting era of scientific discovery. The JWST's revelations about galaxies like GZ9P3 suggest that we might be on the brink of a new understanding of the universe. Whether it's the concept of a multiverse, mirror worlds, or other dimensions, the possibilities are thrilling. As we continue to explore these new ideas, our understanding of the cosmos is set to change in dramatic ways, ushering in a new age of science and discovery. The discovery of GZ9P3 has profound implications for the Big Bang theory, which has been the prevailing model of cosmology for nearly a century. According to the Big Bang theory, the universe began as a hot, dense singularity approximately 13.8 billion years ago, and it has been expanding ever since. However, GZ9P3's existence so soon after the supposed beginning of the universe challenges this model. If galaxies like GZ9P3 were already well developed within just 500 million years of the Big Bang, it suggests that the processes that led to galaxy formation must have occurred far more rapidly than the Big Bang theory can account for. This could mean that our understanding of the timeline of the universe's evolution needs to be significantly revised, or it could indicate that the universe had a different origin altogether, possibly predating the Big Bang. The discovery of GZ9P3 has reignited interest in alternative cosmological theories. One such theory is the steady-state theory, which posits that the universe is eternal and unchanging on a large scale. According to this model, new matter is continuously created to fill the gaps left by the expanding universe, maintaining a constant average density. While this theory fell out of favor after the discovery of the cosmic microwave background radiation, the existence of ancient, complex galaxies like GZ9P3 suggests that the universe might be older and more stable than the Big Bang model suggests. Another alternative is the cyclic model, where the universe undergoes endless cycles of expansion and contraction, potentially explaining the existence of galaxies that seem to predate the Big Bang. These theories provide intriguing possibilities that challenge the conventional understanding of cosmology. The James Webb Space Telescope has ushered in a new era of astronomy, providing unprecedented clarity and detail in the observation of distant cosmic objects. Its ability to peer back in time, to the earliest epochs of the universe, is allowing scientists to study the formation and evolution of galaxies in ways that were previously impossible. The discovery of GZ9P3 is just one example of how the JWST is reshaping our understanding of the cosmos. The telescope's powerful instruments have revealed that the early universe was far more complex and developed than previously thought, challenging long-held assumptions about galaxy formation and the age of the universe. As the JWST continues to observe the cosmos, it is likely to uncover more surprises, potentially leading to revolutionary changes in our understanding of space, time, and the origins of the universe. GZ9P3 is a key piece in the puzzle of galaxy formation in the early universe. Traditional models suggest that galaxies formed slowly over billions of years, starting from small, irregular clusters of stars that gradually merged to form larger and more organized structures. However, the existence of a massive, mature galaxy like GZ9P3 so soon after the Big Bang indicates that galaxy formation might have been a much more rapid and chaotic process. One possibility is that the early universe was a highly dynamic environment, with frequent and violent mergers between smaller galaxies leading to the rapid formation of large, complex systems. Alternatively, GZ9P3 could represent a different pathway of galaxy formation, one that involved the rapid collapse of a massive cloud of gas into a dense, star-rich galaxy. Understanding how such galaxies formed will require a re-evaluation of current models and potentially the development of entirely new theories. The discovery of GZ9P3 has opened up new avenues for cosmological research, prompting scientists to revisit and potentially revise many aspects of our understanding of the universe. One area of focus will be the search for more ancient galaxies that might further challenge the Big Bang model or provide clues to alternative theories. Additionally, researchers will be looking more closely at the processes that could have led to the rapid formation of such a large, mature galaxy so early in cosmic history. This could involve studying the role of dark matter in galaxy formation, as well as investigating the conditions in the early universe that might have facilitated the rapid assembly of massive structures. The JWST, along with other upcoming telescopes and missions, will play a crucial role in these efforts, offering new data and insights that could lead to a deeper understanding of the origins and evolution of the universe.